All right, here we go again. So first, a question for you. What is the best state to get school supplies? Pennsylvania. Why is the library the tallest room in the school? Well, because it has the most stories. Alrighty, so today what we're going to do is we are going to be talking about rate, average rate of change. And to get us started, let's go ahead and read the top of our notes here. We have functions are rules that give us outputs when we supply them with inputs. And we talked about outputs and inputs just recently with our last notes. Often we want to know how fast the outputs are changing compared to a change in the input values. This is referred to as the average rate of change. So you should sound here this word, it's familiar. That's what I'm trying to say. It is familiar because we did have a notes on this once before with graphing average rate of change. Average rate of change, real quick, the last time we talked about it, it was I can't even think of the word, distance over time. So we'll go ahead and write that in real quick. Distance over time. That way it fits in there. Okay, Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start and they run for 20 seconds. The distance they are along in the race in feet is given below, with Max's distance given by the function m of t and Evie's distance given by the function e of t. Okay, so this is utilizing a story problem with some of this average rate of change. So we're going to start with explain the fact that m of 12 equals 30. Find your response on the graph. So after 12 seconds, so we have 2, 4, 6, 8, 10, 12. We're going to go ahead and look at Max's line. We know it'll be this bottom line right here. So, and they said it equals 30. So after 12 seconds, Max is 30 feet from the starting line. So that's how we can explain this is, again, after 12 seconds, Max is 30 feet from the starting line. Okay, and so when it says find your response on the graph, that's what we circled right there, okay? Letter B, if both runners start at t equals 0, okay, when time equals 0, how much of a head start does Max give his little sister? Okay, so that means that their distance will be different. And so it looks like he gives her about a 25-foot start, okay? How can we tell? Because when at e equals 0, this is 25, okay? So we'll go ahead and start that Max gave his sister, oops, sorry, can't seem to write and spell, a 25-foot head start because, and so this is how can you tell, answering that, and we'll go ahead and write when e equals 0 or e of 0, it is equal to 25, okay? So we can also write down this as an ordered pair of 0, 25. Okay, remember as an ordered pair it's x, y. Okay, let's go ahead and do part C. Part C, does Max catch up to his sister? How can you tell? So this will be after the 20-second mark, and it looks like Max does not catch up to his sister. And again, how can we tell? We'll just write down what we see, that when Max is at 20 seconds, he's 50 feet. Evie at 20 seconds is 60 feet. Okay? So first answering that question, no, Max does not catch up. 20 seconds. His sister is at 60 feet, but Max is only at 50 feet. Okay? How far does Max run during the 20-second race? How far does Evie run? What calculation can you do to find Evie's distance? So, since Max is starting at 0, we know that he's running a total of 50. Evie, though, we're going to have to do a different calculation. So she runs to 60 feet, but she starts at 25, or I'm sorry, 25. So it's a simple subtraction, which does equal 35. Okay, so we'll go ahead and answer these questions where Max ran 50 feet. Evie ran 35 feet. Okay, and so because she starts at 25 feet and ends at 60 feet. So it's going to be 60 minus 25 equals 35. All right, so before we go on, I want to quickly have you pay attention to everything that I'm writing down to completely answer these questions. No more simple like 3-word sentences. We need proper explanations. I know your English classes are teaching you how to write sentences with supporting evidence. This is the same thing in algebra. This is, it's getting carried over into algebra. Whenever you are stating information, you need to have supporting evidence for that. Okay, so this is what would be getting you full credit on homework assignments. If I am not getting a good explanation, you will not be getting full credit. Okay, so just I want to make sure that's clear. Okay, let's go ahead and do part E. Part E is how fast do both Evie and Max travel? Okay, so in other words, what are their speeds in feet per second? Express your answer as decimals. So when they're talking about speeds, this is, you know, referring to average rate of change. So that's what we're doing is feet per second, so average rate of change. So I'm going to go ahead and start by labeling my fraction. So it will be feet over seconds. So Max traveled, okay, we just, we're going to use the information from part D. He traveled a total of 50 feet, okay? So looking back at my graph here real quick, from 0 to 50, okay, and so I'm using the y-axis to come up with those values. His total seconds, we're going to use the x-axis, 0 to 20, okay, and then we'll go ahead and simplify. So 50 feet divided by 20 feet is 2.5 or 2.5 feet per second, okay? And then it does say express your answer as decimals, attach units, and so I made sure that we did that. Now we're going to do the same thing for Evie. Evie is in feet per second, and I got a bug flying around here. We just calculated in part D that she traveled a total of 35 feet, the same time from 0 all the way to 60 or 20 seconds. So, and then we'll simplify that. 35 divided by 20 is 1 75/100 feet per second. And the last thing that I'm going to do is mark that since Max has a higher speed, okay, higher average rate of change, he is faster. So Max is faster. Okay, so again, that should make sense. He has a higher number than Evie. Okay, let's go ahead and flip it over. On the back here, this is, you know, what we did on the front, we were calculating the rate that the function's output y values were changing compared to the function's input values or x values. This is known as finding the average rate of change of the function. So you hopefully remember that. Finding the average rate of change is the same as finding the slope of a line. So hopefully you remember that from 7th grade. If not, we'll be doing a lot of that this school year. So some more information about average rate of change. For the function y equals f of x, remember that they equal each other. The average rate that f of x changes from x equals a to x equals b is given by this wonderful formula. So f of b minus f of a. So this is a y minus y over b minus a, which is an x minus an x. So in other words, it's a change in y values over a change in x values. Here's the notation for that, change in y over the change of x. When we're dealing with the graphs, a lot of times you'll hear teachers talk about how it's the rise over the run. And then this last one is probably the more informal formula that we will focus on this school year, okay? It is going to be the 2 different y coordinates subtracted, 2 different x coordinates subtracted. Your key thing is just to remember that it is y over x. And really, it's however you find the change of y over the change of x. So let's go ahead and do a right now. So we'll just focus on all the a's for each different part over here on this back side. So we have to find the average rate of change from when x equals -1 to when x equals 3. So we are given this equation. So our goal right now is when x equals -1, what is the y value? When x equals 3, what is the y value? So when we do that, we're going to go ahead and do the notation. F of -1 is equal to -1 squared plus 3. And then we'll go ahead and simplify and solve this. So -1 squared is 1 plus 3 is 4. We'll do the same thing with f of 3. And so this is going to be 3 squared plus 3. 9 plus 3 equals 12. So what we did, you don't have to do this for your homework, but just kind of reiterate. When x is -1, the y coordinate is 4. When x is 3, the y coordinate is 12. So we're going to use these 2 points and so to find our slope and or our average rate of change. So the next thing I'm going to do is use my formula. M is equal to slope, and for some reason M got left out, so we'll just kind of squeeze that in there real quick. Did you guys see that? We're going to do the change of y, okay? So really you're going to take one y value, subtract it from the other. So 12 minus 4. Since I went with 12 first, then I have to use the corresponding x value first. So 3 minus -1. And then I just simplify. So 12 minus 4 is 8. 3 minus -1 is 4. And then one more simplification. My answer is 2. Okay? And we'll do B next time I see you in class. Okay, we're going to try this again with the table. So what's nice, it's a little bit easier with a table because we don't have to solve for our y values. It is given to us in our table. So remember our table, this is x. H of x is also known as y. So they want to find the average rate of change over the interval 2, which is less than or equal to x, which is less than or equal to 6. So when I have x is 2, my y is 9. When x is 6, my y is 3. So those are the 2 ordered pairs that I'm going to be working with. Okay, if you want to write them out, the ordered pairs are 2, 9, and 6, 3. So those are the 2 ordered pairs. Now we're going to do the same thing. We're going to use that formula that is given up here at the top, okay, where I have slope. And I'm going to just, it doesn't matter which ordered pair you start with. If I start with 3 for my numerator, 6 has to be my denominator. I just need to make sure it's change of y over the change of x. Then I subtract, because again, it's in the formula. So it'll be 3 minus 9, 6 minus 2. And then as I simplify, 3 minus 9 is -6. 6 minus 2 is 4. My final answer, completely simplified, is 3/2. Real quick before we go on, slope is always a fraction, okay? It will never be written. Very rarely is it written as a decimal. It was on the front, but they told you to write it as a decimal. When they don't tell you, we're going to default will be fraction, okay? And we'll do B next time I see you in class. All right, one left to do. So the last one that we're going to do is finding it from a graph, okay? So When we have this graph, they want to find the average rate of change between the following points. So x is negative 6. So when x is negative 6, we have to find the corresponding y values. So we have negative 1, 2, 3, 4, 5, 6. When x is negative 6, y is positive 1. So I'll write that down. When x is positive 4, y is 1, 2, 3, 4, or I'm sorry, that's 4 across and up, 1, 2, 3. 3 is my y value. Okay, and so that's what I'm going to use to find slope. So to do this, again, I just find the difference between the two. Make sure you start with your change of y over the change of x. So 3 minus 1 over 4 minus negative 6. Okay? And then we simplify. 3 minus 1 is 2. 4 minus negative 6 is 10. And completely simplified, that's 1/5. Okay. Hey, that's it for these notes. Thanks so much, guys. I will see you next time.